Hello fellow problem solvers. So today we're going to be doing a problem from the Indian National Math Olympiad 2021, problem number 5. This is a beautiful geometry problem, quite nice, quite lovely, that I suggest you try out for a minimum of an hour, ideally 2 hours, but not more than 3.5 hours. This problem has beautiful solutions, it has horrific solutions, and we will hopefully cover both of them in this video. If on the other hand you would like to go along with us, I suggest you draw the picture, put your first couple of ideas on paper for the next half an hour. So now, let's begin. So this problem was surprisingly short the first time I saw it. And I wanted to use this first sort of thing, as I summarize the problem, to talk a bit about drawing diagrams. Basically, when I saw this problem, the first thing I drew, okay, let's draw the angle ABD. So that's about 30. Okay, we have A, we have B, D, and C is going to be somewhere here. We don't know. Okay, what else? We have BCA 75. Okay, that's a bit difficult, and CD is CB. Okay, so it's a thing on this thing, so we know CD is CB. And BCA is 75. Okay, well that's going to be tough, given the way I drew this just now. So this is 75, and ACD is 25. Okay, this looks nothing like the diagram. So here's the first instructive bit. I tried to draw this, and I immediately saw I should not draw A first. In fact, I should draw, like, once I calculate the angles, because this is equal to this. We have BCD is equal to what? It's BCA plus ACD, which is 100, so these are 40. So the first thing to do is to draw these at 40 and 40, still without a ruler, just so I can get a sense of the plan. Once I get out a ruler, how will I draw it? And now, A is much more natural, much easier. Okay, so I have an angle of 30, and I have an angle of 25 here. Okay, and now I have this. Now this is a much better diagram. And I drew it all by hand, and it's just a matter of what do I draw first. And this is also instructive because in geometry, you can sometimes get ideas about points because you're thinking about how is it that I'm constructing these points. And in this scenario, you don't have any story of construction. But here, you can maybe tell a story of how you draw this triangle here, and then you got an angle of 30. How you get an angle of 30 is another story in and of itself, but this is sort of the story you tell yourself about how you draw this picture. And okay, so we have this is equal to this, and we have a point E such that this will be equal to this. It's on the circumcircle. We need to prove that CE is BD. Okay, so if you haven't already drawn a good diagram and tried a couple of ideas, drawing a good diagram being important, I suggest you do that and try a bunch of ideas for 20 minutes. Now for me, before I drew my better diagram, I also calculated all the angles to see if I have any angle condition that I need to be aware of. And this is 70, 75, 145, so this is 35. And do we have this angle? No, but let's call it X. It's defined, and it also shows up here as X, because these are on the same circle. And with that, we also see, okay, this is 40 minus X, this is 75, we have 65 here, and there's not much progress that can be made. Now, what you do next is, also this is 25 here. What you do next really depends on your style of solving geometry problems. For me, I like to try some synthetic, cool ideas like adding up a couple of points and stuff, and then I like to try a trig bash. If I can't get anything from angle chasing or concyclic points or some other methods I may know. So for me, that is what I did. But I also like to see if I can maybe quickly do a trig bash just from the get-go. And the question is, okay, can we calculate CE? Well, CE, we will have it from this triangle, CE, ED, we will have that this is equal to CD times the sines on the triangle. So CD, opposite CD is X, opposite CE is 40, 80, sine of 80 minus X. And now can I also get BD in terms of CD? Well, the answer is I can. I have BD is equal to CD times, what is this? So we have CD is, we have 40, and we have 800, or 180 minus that, which is 80. Okay, so if these are equal, then we know that sine of 80 minus X over sine of X will be equal to sine of 80 over sine of 40. So this is the question, are these two equal? Well, if they are equal, what do we have? When we multiply them through, we get sine of 40 times sine of 80 minus X is equal to sine of 80 times sine of X. And now we have a rule, we need to know what sine of A times sine of B is. And to do this, we remember our cosine rules. So to do trig bash, you need to know, basically you only need to know two things. What is cosine of A plus and minus B? And sine of A plus and minus B. If you know these two, you can get any other thing. You can get sine of A plus sine of B. You can get a sine of A cosine of B, and whatever combination you need. And the way I usually like to test these out, I know cosine has cosine of A and cosine of B first, and then it's minus plus sine A sine B. And the way I know it's minus plus is I plug in 30 and 30, A is 30, B is 30, and I see if these things match up. And when you plug that in, you figure out, oh, it matches up like this. And now given we know this, it means that sine of A times sine of B will be cosine of A minus B minus cosine of A plus B. So we can only have the sines and get rid of the cosines. And this also divided by 2. And now if we do that here, what we'll get is cosine of 40 minus X minus cosine of 120 minus X is equal to cosine of 80 minus X minus cosine of 80 plus X. So these are all question marks. Are these equal? And this is also in geometry what I call solving the problem backwards. Looking at what if the thing that we need to prove is true, what else holds? So maybe we can figure out what X needs to be or what relationship it needs to satisfy. And then from there, we can maybe prove that. And now when you're doing trigonometry, the only important part is that you don't make any mistakes, because this is really, you are trying to bash it, is the term. You're brute forcing the problem. So, and it's important that you don't get a wrong idea of what X is or should be. Now with this, I will be playing around with trigonometry. A lot of it is just play. And maybe I'll just show you one more thing, which is how I get cosine of A plus cosine of B. And it's a trick. And I said that the only thing you really need to know is this. What's the cosine of A plus and minus B and sine of A plus and minus B? Because if you want cosine of A plus cosine of B, if you set A to be equal to x plus y and B to x minus y, where x, y are some other numbers, you will get this thing right here will be equal to cosine x, cosine y, minus sine x, sine y, and this other thing will be equal to cosine x, cosine y, plus sine x, sine y. And as you can see, you will get that this whole cosine A plus cosine B is going to 2 cosine x, cosine y. And now if you subtract and divide by 2, you get x is A plus B over 2, and y is A minus B over 2. So you get 2 cosine of A plus B over 2, cosine of A minus B over 2. And now, let's proceed with the trig bash. And we came here. This is a long journey. Basically, what we got using a lot of trigonometric manipulations is that either sine of 50 times 2 times cosine of x minus 30 is minus 1, or the sine of 30 minus x is 0. If either one of these is true, then we have the problem holding. Now, if this were true, that means cosine of x minus 30 would have to be negative, and the negative cosine is here, which means x minus 30 would have to be here, which in turn means that, so x minus 30 must be an element of 92 to 70, which means x must be an element of 120 to 300. And now, given our diagram, this seems unlikely at the very minimum. So if this was 120, I think, yes, the sum of all the angles in this whole picture would be greater than. So this is probably false, which means that in all likelihood, we will have to prove that x sine of 30 minus x is 0, and sine 0 here and here. So either 30 minus x is 180, not likely, or 30 minus x is 0, which means that x is 30 degrees. And now with this, we know what our end goal is. Our end goal is really to prove that this angle right here is 30 degrees, and we can forget about E. So this is a valid problem-solving strategy. You look at a problem backwards, what it is we need this to be true, use some trigonometric manipulations, and get that. This will be true in our problem if and only if x is going to be 30 degrees. And now we have a new target, proving that this is 30 degrees. And now with this target in mind, I invite you to pause for 20 to 30 minutes and see what ideas you will come up. Like, what would you do here in this problem right now? And what I'm going to do right now is show you a different flavor of things I tried after I figured I needed to prove this is 30. Here's my next step. So, in all honesty, I will tell you what I first tried to see. I tried to see whether or not I could finish this immediately. And the answer is, I can, but it is very, very ugly. But I just want to show you the technique. Basically, we have all these angles. And if we have these angles, this one, this one, this one, this one, this one, this one, that uniquely defines x. And there's a way we can find x using trigonometry. Basically, we know that the sine of x over sine of 115 minus x is equal to what? md over ma. Similarly, we have sine of 35 over sine of 30 is equal to what? mb over ma. Actually, we will use the opposite, ma, mb. And as you may be able to figure out what we're going to be doing now, we'll have sine of 75 over sine of 40 is going to be equal to mb over mc, and sine of 25, sine of 40 over 25 is going to be mc over md. And when we multiply all of these together, what we get is 1 on the right-hand side. All of these cancel out. And we're left with sine of x over sine of 115 minus x, and a couple of these things. And the sines of 40 cancel out as well. So what we get is this right here, sine of x or sine of 115 minus x is equal to this. And from here we can keep using trigonometry, use a bunch of these things, manipulate them, and use the fact that if sine of alpha minus x over sine of x is equal to sine of alpha minus y over sine of y, this implies x is equal to y. And you can prove this identity using trig formulas. It's a useful lemma to know when doing trigonometry. So I will not be finishing the problem up like this. I'll be now showing you a couple of synthetic solutions that you can look at. Okay, so one of the questions is, okay, we need to prove something with BE, and BE equals CE equals BD. And now maybe one of the ideas is, what happens if we just put this over here, like make this angle such that this is 70 and 70, and then this is 5. Then we have B, call this X, BX is BC. And now we need to prove that XD is BE. And really what I tried to do here is I tried to add various different kinds of points and see if anything worked. Was there anything that made any sense? If I'm trying to get CB, let me see if I can maybe get it like this, if I put it in this point. And really, this is a point where you're exploring your, say, CY is CB. You're exploring and you're trying to figure out, do any of these things give you interesting conditions? And now I invite you to actually pause for 20-30 minutes and explore different kinds of points you could add. You could get BD by translating D over BA or over BC. You could get a point here such that D, call this point Z, DZ is DC. And then you need to prove that BZ is BE. Or you could even forget about the point E and just focus on proving this is 30. But try and see like what kinds of points you would add. Maybe use the fact that what do you get from 30? I invite you here to pause and play around with that. Take 20 minutes. And now here are a couple of ideas. So the first idea is maybe playing around and figuring it out and just like stumbling upon it, or maybe noticing something peculiar. Namely, this angle is half of this angle. I have this twice, CB and CD. So let me draw a line such that CB is equal to CX and X is on the line AB. So this is that point. Let's call this point T. And now we have CB is equal to CT is equal to CD. This is 40, this is 10. This thing right here is what we have 40. This whole thing needs to be 50, so this is 25. This is also the angle bisector of this. This is 90. And now we know that CB is CT, but also because this is 35 and this is 35, we also know that CT is equal to TA. So this makes it an interesting point to look at because there's a lot of things connecting the angles together. Now take 5 to 10 minutes with this point. Here's the next thing you notice. This thing right here is 60. This is equal to this, which means that we can get it from many ways. We can get it C is the circumcenter of BTD. So this angle right here is 20, which makes this 20 plus 40, 60, 60, which makes this 60, and also makes this angle right here 50. But more importantly, TD is also TC, is CD, is TA, and now we have this is 50, and that makes both of these angles, because TD is TA, that means both of these angles need to be what? 180 minus 50 over 2, which is 65, which means this angle is 30, and this angle right here is what? 20, 45. And now with that, we can use our trigonometry thing we figured out to finish the problem up. Also, this angle is 65, not 45. Now you can either finish up with trig, or nicely you can notice that TA being TC being TD implies what? Well, it implies that T is the circumcenter of this circle that's around ADC and that point E. So now you will know that once you join T and E, you know TE is TC. So you know this thing right here is 40. And now notice that from TE, TC, we have this is 40, 40, TE is TC, CB is CD, this is 40, 40. We have that the triangles BCD and CTE are congruent, and we are done. And now with this, let's move on to a different type of synthetic solution we could have gotten. Here's the second idea, and with this one you still have the point E in your mind. And what you're thinking is, here's an angle 30. I want something else that's also BD. And you're trying to do something here, and what you also notice is this angle 30 is very nice, that DBA is 30, because we can reflect D, and what we'll get is an equilateral triangle. So you try that out, that's the idea, and what we get is, so now that we reflected D, we have this is 60, this is 30, this is 60, call this point D prime, we have BD is DD prime, is d prime b. Now, also notice because d prime d is d prime b and cb is cd, this thing right here is a kite. So actually, we can just connect these things right here. And we have that this is equal to this. And we also know that d prime a is dA due to our reflection. And now we use a lemma. The first part of the lemma we use is that because this is this equal to this, and this is the angle bisector, AC is the angle bisector of d prime CD, we know that A lies on the circumcircle of CD d prime. You'll prove this lemma by introducing a phantom point. Take the intersection of CA with the circumcircle of CD d prime, and you will get that this point is also equidistant to D and D prime, but there's only one such point that's equidistant, and which is a bisector. So, with that in mind, we know that D prime is also on this circle. Now, due to it being the angle bisector of this thing, of the angle ECD, we know that ED prime is going to be equal to D prime D. And you can get this simply by angle tracing. When you connect these, you'll get this is 50 and this is 50 because of these angles. And now, with that in mind, we have this is equal to this is equal to this is equal to this. So the thing we need to prove is that D prime E is EC. And how do we do that? And we prove that how? Well, via angle tracing. Namely, this is 50. We know because we know here we have 30, 30, 40, which makes this angle right here what? 30 plus 30 plus 40 is 100, so we're left with 80. So there's 80 here, now there's 80, 50, which makes this one 50, and now we know that ED prime is EC, and we've proved what he needed to prove. Now there's a way to write all of this up. We also, in this case, did not even need to figure out that this angle is 30, though we get it quickly. And by quickly, I mean we get it when we figure out that these 4 points are on the same circumcircle. And using the fact that this is an angle bisector, that both of these are 30. And with that, I invite you to take 10 minutes and write up a solution. Here's our write-up. So I'm going to write up the trig bash brutality solution because that's the one that will be hardest to make yourself. All these other write-ups are pretty straightforward. So the first thing we do is we calculate the angles. And now that we've calculated these angles, next thing we do is write the sines. And after calculating BDA, we write the sines like this. And now we say that 1 is equal to 2 times 3 times 4. And that this implies that sine of x over sine of 115 minus x is sine of 35 over sine of 30 times sine of 25 over sine of 75. And now, the second thing we do is we prove that sine of 35 over sine of 30 times sine of 25 over sine of 75 is sine of 30 over sine of 85. And the way we do this is via a bunch of trigonometry. Basically, we have if and only ifs, and we get to this thing, which is true because sine of A plus sine of B is equal to what it is. And now with that ready, we move on to step 3. We prove the lemma if x and y are between 0 and alpha is less than 180, and we have that sine of alpha minus x over sine of x is equal to sine of alpha minus y over sine of y. This implies x equals y. Remember this lemma because quite often it comes in handy. And the way we prove it is we do with this a bunch of trigonometric transformations, and we get that this is true if and only if x is equal to y, or alpha is 180. And given alpha is less than 180, this implies x equals y. Now, applying this lemma to the thing we found here, namely that sine of x over sine of 115 minus x is equal to sine of 30 over sine of 85, which is equal to what? 115 minus 30. Applying this lemma, we get that x is equal to 30. And with this, we move on to the final trig bash, namely we get CED and BDE, CED being 30 and BDE being 10. And now we have BE is sine of 10 over sine of 30 times BD, BC is sine of 40 or sine of 80 times BD. And now BE plus BC is CE. And then CE is equal to BD times this, which we transform once. We're using that. Sine of 2 times 40 is 2 times sine of 40 cosine of 40. We have this. Then we use sine of A cosine of B is equal to what? It's equal to sine of A plus B minus sine of B minus A. And then we have this. And then we evaluate sine of 30 as a half. And we get sine of 50 cosine of 40. They are the same. And from here we have CE equals BD, which is what we needed to prove. And as always, thanks for problem solving.